Welcome back. So we've talked about the cosine transform, the discrete cosine transform, the 2D cosine transform, and now we're going to talk about the discrete 2D cosine transform, or the 2D DCT. So, first, the definition. Like the 2D cosine transform, the 2D DCT is simply created from the 1D transform. So if we have a 1D transform, 1D DCT, as we talked about it previously. Then we just define our 2D like this. JK MN is equal to the product of two 1D bases. So that will form the basis set for our 2D DCT, and we get 2D JK M comma N. Put the J and K are both between 0 and n minus 1 inclusive. There we go. So I've plotted what this actually looks like if you plot the 2D DCT, and we can now see that. If we have n is equal to 8, this is actually used in JPEG and MPEG compression. It looks like this. So it's excuse me. Look at what's going on here. So first, if we look at the upper left, we have J and K are both 0. And so then we would be looking at J equals 0, K equals 0, and M. Actually, the way I did it before, it should be the other way around. K equals 0 is here. J is on this axis. And so M and N are the indices into these actual blocks. And since this is all constant, it's maybe hard to see where that is. But for J equals 0 and K equals 0, it's constant in both dimensions. Now if we go over here, to the right, we have K equals 1, J equals 0, so it's still constant in the J direction, but in the K direction you can see we have half a period of a cosine. Where it's white is where it's high. So if we were to look at the profile here at K equals 2, we would see something like that, and on this axis it's constant. So as we move our way down, here, where they're both equal to 2, for example, we're going to have the product of these two. So that point is the product of those 2 points, this point is the product of, I'm going to try that in a different color. Well, actually, it may not work. This point is the product of those 2 points, which are both negative, so you get this positive value up near 1. Okay, so as we go through, then we have all these different shapes. As we move down, we get to higher and higher frequencies until at the end we're at very high frequencies where it's alternating with every sample. So that's our 2D DCT. When we, right here, we've plotted the product of the functions, but when we actually compute the 2D DCT, the coefficients are indexed by J and K, so we tend to arrange them in a grid. So the 2D coefficients are indexed by 2 integers. So we arrange them in a grid, something like this. Alpha 0, 0, alpha 0, 1, alpha 0, 2, and so forth. Alpha 0, n minus 1, alpha 1, 0, and so on and so forth. So at the bottom we have alpha n minus 1 and n minus 1. So that's our 2D DCT. Next lecture we're going to take a little bit of a detour from the theory, and we're going to talk about JPEG compression. And so, talk to you then.